Let's take a look at this geometry problem. We have a right angle triangle ABC, so this angle is 90 degrees, right? And then we know the side length AB is 3. The side length BC is 3 plus 5, that's 3 plus 2, that's 5, right? This length is BD is 3, DC is 2, so BC is 5. And we know that E is in the middle of AC, so AE equals to EC, and we need to evaluate the area of this triangle AFE. Right, so what's going to be the area of AFE? So how we are going to evaluate this the area of this triangle, right, AFE? So we're going to look at the proportion of AFE inside of this bigger triangle ABE, right? So if we can find out what's actually the proportion of AFE inside of the ABE, then we can find out the area, right? Because we know the area of ABE. Why is that, right? Because the area of ABE is actually 1/2 of the area of ABC, right? So the area of ABE is 1/2 of the area of ABC, right? And then what's going to be the area of ABC? Why is it 1/2, right? Because if we treat this AE as the base of ABE, then the height is over here. Its height is over here, right? And then if we treat AC as the base of ABC, then it's the same height, right? So the area is just going to depend upon the base because the height is the same. And the base of this ABE is AE, right? AE is 1/2 of the AC, which is the base of ABC, right? So the area is just going to, because the height is the same, so the area is just going to depend upon the base, right? And the base is 1/2 of it, so the area is going to be 1/2 of it. And ABC is what? It's 3 times 5, right? Divided by 2. So it's 1/2, 3 times 5. So it's 15 over 4, right? So that's going to be the area of ABC. Okay. That's going to be the area of ABE, right? So that's the area of ABE. So to find out the proportion of AEF inside of the ABE, all we need to find out is the area of AFE and the area of ABF. What's the ratio between them, between these two triangles? Then we know what's actually the ratio of the proportion of AFE inside of the ABE, right? So what we want to do is to find out the area of AFE, this triangle, over the area of, well, ABF, right? Right. If we look at these two triangles, the height is going to be the same. Actually, it's over here, right? And then for AFE, the base is going to be FE. And then for ABF, the base is going to be BF. The height is the same, right? So the area ratio is going to depend upon, it's going to be the base length ratio, right? So it's going to be equal to FE over BF, right? So FE over BF equals to what? FE over BF is going to equal to, now let's connect this 2 points E and D with a dash line, right? So FE over BF is going to equal to the area of AD over the area of ABD. Why is that? The area of AED over the area of ABD. Why is that, right? If you watched one of the videos, one of my previous videos, you know why it's true, right? Because these two triangles ADE and ABD share the same base AD, right? So AD is shared by these two triangles, right? So the area ratio, the ratio of the area is going to be the ratio of the height. The base is the same. So the height of AED is going to be like this here, right? And then the height of ABD is going to be like over here, right? So that's a 90-degree angle, right? So if you look at these two triangles, they are similar to each other, right? So the area ratio equals to the height ratio, right? So that's height ratio, this length over this length. And these two triangles are similar to each other. So the ratio of this length over this length is the same as the ratio of EF or FE and BF, right? That's exactly this ratio, right? Why these two angles are similar to each other? Because this angle is the same, right? And then this is 90 degrees because it's the height. So it's the height. So it's height to this common base, right? So these two angles are the same, and the third angle is also must be also the same, right? So these two triangles are similar to each other. So that's why the ratio of these two heights is going to be the same as the ratio of FE over BF, right? And the ratio of the two heights is going to be the same as the ratio of these two areas, ADE and ABD, right? Because they share a common base. So now let's look at what's going to be the area of AED and then ABD, right? The area of ABD is relatively simple, right? The area of ABD is going to be 3 times 3 divided by 2, right? What's going to be the area of AED, right? The area of AED is going to be 1/2 of the area of ADC. Why is that? Why is that, right? Suppose if we look at the triangle AED and use AE as a base, then the height is going to be like over here, right? And then if we look at the triangle ADC and use AC as a base, the height is still over here. It's the same height, right? So the area is going to be just depend upon the base, right? And we know that AE is 1/2 of AC, right? So that's why the area of AED is 1/2 of the area of ACD or ADC, right? And then what's going to be the area of ADC, right? What's going to be the area of ADC? It's going to be the area of this triangle. If we treat this DC as a base, right? And then the height is going to be AB, right? So the area is going to be 2 times 3 divided by 2. Right, so it's going to be 3 over 2, right? So now we know the ratio. It's 3 over 2, right? AED is 3 over 2 divided by ABD. ABD is 9 over 2. So that's going to be 1/3, right? 1/3. So the area of AFE, if we denote it as X, so S triangle AFE equals to X, right? Then the area of ABF is going to be what? It's going to be 3x because the proportion is 1 to 3, right? So the area of ABE is going to equal to the area of ABF plus the area of AFE, right? AFE is x, ABF is 3x, that's 4x, right? And we know that the area of ABE is what? The area of ABE is 15 over 4. So x is going to equal to what? X is going to equal divided by 4. It's going to be 15 over 16. Right, and that's our answer. The area of this AFE is 15 over 16.